from Morogoro. My name is teacher RAMADHAN KADEGHESHO. I'm a Form 4 chemistry teacher. Today, I'm going to proceed to teach organic chemistry, and I will teach the subtopic of alcohol. So, what is alcohol? By definition, you can say alcohol is organic compound with hydroxyl group as a functional group. Alcohol is organic compound with hydroxyl group as the functional group. This is the definition of alcohol. So in alcohol, the functional group of alcohol is hydroxyl group or OH group. So OH group is called the hydroxyl group. The systematic name for alcohol is called the alkanol. Systematic name for alcohol is called alkanol. Alcohol can be represented as ROH. ROH, where R represents the alkyl group. R represents the alkyl group. So the general formula for alcohol is ClH2n plus 1 OH. ClH2n plus 1. C is carbon, H is hydrogen, and N represents the number of carbon atoms. In case you have 2 carbon atoms, you substitute in this N. Alcohol, named by taking the name of alkanes and changing the end ane with anol. Alcohol is named by taking the name of alkanes and change the end ane with anol. For example, methane, you say methanol. Ethane, you say ethanol. Propane, you say propanol. You change ane with anol. Now, homologous series of alcohol. We have already discussed a lot about homologous series, so we go direct to the homologous series of alcohol. Here, this table shows the homologous series of alcohol. Starting with the first alcohol, which is the methanol. The number of carbon for methanol is 1, and the molecular formula for methanol is CH3OH. Ethanol is the second compound, or is the second compound of what? Of alcohol. The number of carbon for ethanol is 2, and the molecular formula is C2H5OH. Propanol, 3 carbon atoms. It is C3H7OH. Butanol is C4H9OH. Pentanol, 5 C5H11OH. Hexanol is 6. It is C6H13OH. And heptanol is 7, which is C7H15OH. Octanol is 8, is C8H17OH. Nonano is 9, it is C9H19OH. Finish with decano is 10, is C10H21OH. So these are molecular formula which is derived from general formula which we have already discussed earlier. We have already discussed it here. So if you substitute the number of carbon here, you obtain the molecular formula as shown here in this homologous series of alcohol. Okay, classification of alcohol. Classification of alcohol. Alcohol are classified into 3 main groups, depending on the position of hydroxyl group in the main carbon chain. Which are those? The first group is the primary alcohol. The second one is secondary alcohol. And the third one is tertiary alcohol. These are 3 classes of alcohol. Now, I'm going to explain one after another, starting with primary alcohol. In primary alcohol, the carbon atom carrying the hydroxyl group is attached to only one other carbon atom. I'm repeating again. In primary alcohol, the carbon atom carrying the hydroxyl group is attached to only one other carbon atom. Let us look at some examples here of primary alcohol. For example, this one here. This is a propan 1-ol. 1, 2, 3. It is a propan 1-ol. So this carbon here is carry OH group. This carbon here is carrying OH group. So this carbon which carrying OH group is attached to only one other carbon, to a single carbon. So this is one of the examples of primary alcohol. Another example, this one is called propan 1-ol. Another example here is this one. It is called 1,2,2-methyl propan 1-ol. 2-methyl propan 1-ol. As you see here, the carbon which carries OH group, this carbon here is the one which carries OH group, is attached to only one carbon. So this is another example of primary alcohol. Now, secondary alcohol. In secondary alcohol, the carbon atom carrying the hydroxyl group is attached to 2 other carbon atoms. So this secondary alcohol, I mean that carbon which carrying hydroxyl group is attached to other 2 carbon atoms. Let us look at some examples here. For example, the first example here is this one. It is propan 2-ol. 1, 2, 3. It is a propan 2-ol. The carbon, this one carbon here, carry OH group. This carbon here carry OH group. But this carbon here is attached to other 2 carbon atoms. The first carbon which is attached to this carbon which carry OH group is this one, and the another one is this one. So you have 1, 2 which is attached to this carbon which carry OH group. So this is an example of secondary alcohol. Another example of secondary alcohol is 3-methyl-butan-2-ol. 3-methyl-butan-2-ol. If you look at this compound here, the IUPAC name of this compound is 3-methyl 1, 2, 3, 4. 1, 2, 3. 3-methyl-butan-2-ol. So in this compound, this carbon here carry OH group. This carbon here carry OH group. But this carbon is attached to other 2 carbon. The first carbon is this one, and the second carbon is this one. So this also is another example of secondary alcohol. Clear? Now, number 3 is tertiary alcohol. The 3rd class of alcohol is tertiary alcohol. Now, in tertiary alcohol, the carbon atom carrying the hydroxyl group is attached to 3 other carbon atoms. In this one, tertiary alcohol, the carbon that carrying hydroxyl group is attached to 3 other carbon atoms. Go direct to the example. Is this one here. If you look at this example, the name for this example is 1, 2 is 2-methyl propan 2-ol. 2-methyl propan 2-ol. But this carbon here carry OH group. As you look at this carbon here, is attached to other 3 carbon atoms. Is attached to this one, and this one. So this compound is called tertiary alcohol. Is an example of tertiary alcohol because the carbon which carry OH group is attached to other 3 carbon atoms. Now, the summary for the classes of alcohol are as shown below. This is the summary. This is the alkyl group. For the first example, this is an example of primary alcohol because the carbon which carry OH group is attached to one alkyl group. The second here is secondary alcohol. Why secondary alcohol? Because the carbon which carry OH group is attached to two alkyl groups. And the third one here is tertiary alcohol because the carbon which carry OH group is attached to 3 alkyl groups. This is the summary for classes of alcohol. Now, naming of alcohol. We're going to look at the rules for naming alcohol. Starting with the rule number 1. The longest carbon chain or parent chain must contain hydroxyl group. So the hydroxyl group must be in longest chain or in parent chain. If it is out of longest chain, we cannot consider as a parent chain. We cannot consider it as a parent chain. For example, here, in this compound here, how to identify the longest chain for this compound? The hydroxyl group is this one here. Now, this hydroxyl group must be included in the parent chain. So the first carbon which carries, or the carbon which carries OH group must be included in the chain. Now, the first carbon will be this one, 1, 2, 3. Here you have two options. The first option is 1, 2, 3. The second is 1, 2, 3. So you can choose any option. If you want the first option, it will be 1, 2, 3, and this one is the longest chain. It is propanol. The parent name for this one is propanol because it contains 3 carbon atoms. Okay. Rule number 2. Parent chain is numbered in such a way that the carbon atom having hydroxyl group give the latest possible number. What do I mean? The hydroxyl group must be nearest the end. You number from the end which is the nearest hydroxyl group. For example, this compound here, if you identify the longest chain, you will start with this carbon. It will be, because it carries OH group, it will be 1, 2, 3, 4, 5, 6. Option number 1. 1, 2, 3, 4, 5. Option number 2. The option number 2 has small number of carbon atoms. So you take the option number 1, which is 1, 2, 3, 4, 5, 6. Now, for a case of numbering, you number from the end nearest hydroxyl group. The hydroxyl group is in this carbon here. The hydroxyl group is in this carbon here. Now, if you start from left to right, it will be 1, 2, 3, 4, 5, 6. The hydroxyl group in the 6th carbon. But if you start from right to left, it will be 1. So 1 is smaller than 6. For that case, numbering will start from right to left. It will be 1, 2, 3, 4, 5, 6. And the name for this compound, it will be, because methyl group, we name as in alkane, alkene, and alkyne. We start with the substituent group. The methyl group is in the 4th carbon. It is 4-methyl hexane 1-ol because 1 is the locator for OH group. 1 is the locator for OH group. So it is 4-methyl hexane 1-ol. Another example is this one here. Now, how to name this compound? First of all, I say that to identify the longest chain. Before numbering, we start to identify the longest chain. So the first option here, it will be 1, 2, 3, 4, 5, 6. The OH group is included in the chain. The carbon which carries OH group is included in the chain. So it is 1, 2, 3, 4, 5, 6. That's the first option. The second is 1, 2, 3, 4, 5, 6. So you can choose. the option number 1 or option number 2, all are acceptable because the number of carbon atoms are the same for all options. So for that case, it will be 1, 2, 3, 4, 5, 6. This is the longest chain. And the CH3 here is in the 5 carbonic, but OH, now it is a matter of numbering. Numbering will start from the end nearest OH group. OH group is in this carbon here. Now, if you start from left to right, it will be 1, 2, 3. OH is in the third carbon. But if you start from right to left, it will be 1, 2, 3, 4. 4 is the locator for in case you start from right to left. Now, because 3 is smaller than 4, for that case, numbering will start from left to right, and it will be 1, 2, 3, 4, 5, 6. And in naming the compound like this one, first of all, we start by naming the substituent group. We have one substituent group here, which is methyl group. Is in the 5 carbon, so the locator for methyl group is 5. It will be 5 methyl. Then, because there are 6 carbon atoms, it is hexane 3 all, because the locator for OH group is 3. So it is 5 methyl hexane 3 all. This is the name for this compound. After that, rule number 3. For alcohol with more than 2 carbon atoms, for alcohols with more than 2 carbon atoms, the position of hydroxyl group must be indicated in the name. In case your alcohol has more than 2 carbon atoms, I mean from propanol has 3 carbon atoms. As you go up, the position of hydroxyl group, what do I mean here? The locator for hydroxyl group must be indicated. The locator for hydroxyl group must be indicated in the name. For example, a compound like this one here. As you see here, the first rule I said is to identify the longest chain. It is 1, 2, 3, 4, 5, 6. A 6 carbon atom. The second rule here is to number. Numbering starts from the end nearest OH group or nearest hydroxyl group. So 1, 2, 3. 1, 2, 3, 4. You start from left to right. It is 1, 2, 3, 4, 5, 6. Then number 3. Then the name for this compound, it will be, because here you have a substituent group which is a methyl, is in the 5 carbon. You will start with 5 methyl, then it will be hexane 3 all. 5 methyl hexane 3 all. Z3 is the locator for OH group. Is the position of OH group. Must be included in the name. As in the name here, it is shown here. This must be included. In case your compound has more than 2 carbon atoms, from propanol, the locator for hydroxyl group must be included. Must be included in the name. So, from the example above, the locator of OH is 3. As shown here, 3 is the locator for OH group, and for that case, the name will be like this one. 5 methyl hexane 3 all. So this 3 is the locator for OH group. 3 is the locator for OH group, and the 5 is the locator for substituent group. So this 3 must be included in the name. Rule number 4, if hydroxyl group is in center, in case hydroxyl group is in center, numbering starts from the end nearest substituent group. For example, for the compound like this one here, In case you start by identifying the longest chain, it will be 1, 2, 3, 4, 5, 6, 7. First option. Second, it is 1, 2, 3, 4, 5, 6, 7. So any option can be acceptable. Is acceptable. Any option is acceptable. After that is to number the longest chain. And numbering starting from the end nearest OH group. The OH group is here in this carbon. Now, if you start from left to right, it will be 1, 2, 3, 4. But if you start from right to left, it will be 1, 2, 3, 4. So OH group is in center. So for that case, what to be considered when numbering this compound or the parent chain of this compound? The point to consider now is the substituent group. We number from the end nearest substituent group. Here we have one substituent group, which is this one here. Now, from this substituent, if you start from left to right, it will be 1, 2, 3, 4, 5, 6. It will be 6. But if you start from right to left, it will be 1, 2. So 2 is smaller than 6. For that case, numbering will start from right to left. And it will be 1, 2, 3, 4, 5, 6, 7. So this is heptanol. And the name for this compound will be, because the substituent group is in the second carbon, it will be 2-methyl-heptan-4-ol. The locator for OH group is 4. So it is 2-methyl-heptan-4-ol. This is the IUPAC name for the compound like this one. Okay, now let us look at some examples. Oh, we have a last rule here. We have a last rule. First, let us discuss it. Let us explain it first. Then we will look at some examples. The rule says, if there are more than one hydroxyl group, if there are more than one hydroxyl group, the name ends with suffix diol for 2, triol for 3, and tetraol for 4, etc., etc. So if there are 2 hydroxyl groups, will end with the suffix diol. If there are 3 hydroxyl groups, we end with the suffix triol. And if there are 4 substituent group, 4 hydroxyl groups, we end with tetraol, etc., etc. For example, the compound like this one, you want to name the compound like this one. The first thing I said is to identify the longest chain, and the longest chain must include the hydroxyl group. So for that case, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the OH group, the first OH group is this one, the second is this one, the third is this one. All hydroxyl groups are included in the parent chain. So the parent chain contains 9 carbon atoms. So it is nonano. Now, the second is to number. And numbering starting from the end nearest OH group. If you start from left to right, the first OH is in 1, 2, is in the second carbon. But if you start from right to left, the first OH is in the first carbon. The OH group is in the first carbon. So for that case, because 1 is smaller than 2, the numbering will start from right to left. And it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the parent chain. Start from right to left. After that, what's follow is to name the substituent. And here we have one substituent which is a methyl, is in the third carbon. So it will be 3-methyl nonan 1,5,8 triol. 3-methyl nonan 1,5,8 triol. Why triol? Because there are 3 hydroxyl groups. If if there are 2, you name diol. If 4, you name tetraol, etc., etc. So it is, and this locator for all hydroxyl group must be included between the non and all. Must be included in the name. The locator for this hydroxyl group 1,5,8 triol. So this is the parent chain. This is the IUPAC name for this compound. Now let us look at some examples. We have a plenty of examples. We cannot explain all of it because there are many compounds of alcohol. Now, the first name the following alcohol. We have the alcohol here. Then they want you to name this alcohol. As I said, the first role is to identify the longest chain, and the longest chain must include OH group. For that case, we will start with this one. 1, 2, 3, 4. The first option is 1, 2, 3, 4. That's the first option. The second, 1, 2, 3, 4. The second option. The third, 1, 2, 3. So the first option and the second option are acceptable. You can use the first option or second option, but third option contains the few number of carbons. It is 3. Here we have 4, we have 4, we have 3. So for that case, now the longest chain you can take the first option or you can take the second option. You can take the first option or you can take the second option. So for that case, it is 1, 2, 3, 4. Let us take one option. It's 1, 2, 3, 4. This is our option. Now, after identify the longest chain, what's follow is to number. And numbering starts from the end nearest hydroxyl group. The hydroxyl group is in this one, this carbon here. Now, if you start from left to right to account the number of carbon, it will be 1, 2, 3. Then hydroxyl group. But if you start from right to left, it will be 1, 2. So 2 and 3. 2 is small. Now numbering will start from right to left. It will be 1, 2, 3, 4. This is the first carbon, second, third, and fourth. After numbering the parent chain, what's follow is to name the substituent first. Here we have 2 substituents. We have this substituent and this substituent. All are methyl. There are 2 methyl groups. So how to name them? You write the locator number for these, and then because they are 2 and all are the same, you use diol. Use di. So it is 2,3 dimethyl. 2,3 dimethyl butan 2-ol. 2,3 dimethyl butan 2-ol. Why butan 2-ol? OH group is in the second carbon, as you number from left, right to left is in the second. So this is the locator for OH group, and these 2 and 3 are the locator for methyl groups. So for that case, it is 2,3 dimethyl butan 2-ol. This is the IUPAC name for this compound. Now let us look at another example. Is this one here. In case you have a compound like this, how to identify the longest chain? And the point to remember is that the OH group, the carbon which carries hydroxyl group, must be included in the chain. So the hydroxyl group is in this carbon. Now, the first carbon to be accounted will be this one. Now, you look at all options of the chain. The first option will be 1, 2, 3, 4, 5. This is the first option. 1, 2, 3, 4, 5. The second, 1, 2, 3, 4. The third, 1, 2, 3, 4. 1, 2, 3, 4. So the first option, we'll take the first option because it contains the main number of carbon atoms. It is 1, 2, 3, 4, 5. Now, after identifying the longest chain, what's follow is to number. If the chain is this one, 1, 2, 3, 4, 5, is this one is your chain. Now what's follow? What's follow is to number, and numbering will start from the end nearest hydroxyl group. The hydroxyl group is in this carbon. It is in the first carbon. If you start from right to left, it is 1. But from left to right, I think that it will be 5. So numbering will start from right to left. It is 1, 2, 3, 4, 5. At this case, what's follow is to name first substituent groups. The first substituent group is this one here. It is called chloromethyl. It is called chloromethyl. And the second one is this one. It's called isopropyl. So we have isopropyl here, and we have chloromethyl. Now, the chloromethyl is in the 1, 2, 3, third carbon. So it is the 3 chloromethyl. But the isopropyl here is in the 1, 2, is in the second carbon. So it will be 3 chloromethyl, 2 isopropyl, pentan, 1 ol, because OH is in the first carbon. So it is 3 chloromethyl, 2 isopropyl, pentan, 1 ol. This is the IUPAC name for the compound, for this alcoholic compound. Now another example is this one here. Another example is this. For the example like this one here, as I said, the first role is to identify the longest chain. And here, the first option, the first carbon is this one here. So for the first option to be 1, 2, 3. 1, 2, 3. This is the first option. The second, 1, 2, 3. The third, 1, 2, 3. So all options, any option of these 3 are acceptable. If you take this 1, 2, 3, it is acceptable. If you take this 1, 2, 3, it is acceptable. 1, 2, 3, it is acceptable. And the answer will be the same for all. Now, after identifying the longest, let us say our longest chain is 1, 2, 3. This is our longest chain. After that is to number. And numbering is starting from the N nearest OH group. The OH group is in this carbon here. It is this one here is in this carbon. So numbering will start. It is in the first carbon. It will start in this carbon here. 1, 2, 3, and not from. It will start from right to left and not left to right. It is 1, 2, 3. Now after that is to name. First of all, we have to name the substituent group. The first is methyl group, the second is methyl group. So we have 2 groups here, methyl group, methyl. So it is the methyl. Now it will be 2, 2 methyl because all of them are in the second carbon. So it will be 2, 2 methyl propan 1 ol. 2, 2 methyl propan 1 ol is the name of this organic compound or alcoholic compound. Now, exercise. I have a question here which says give the IUPAC name for the following compounds. I have some compound here. The first compound is this one, CH2, CH3, then CH2OH, CH3, CHOH, CH3. I think by using examples which I explained earlier, it is very possible to name this compound because I have already explained the example which look the same like this compound. So it is very possible to name this compound. You have to try it. Also, this one here, I have already explained. This one here, I have already explained. It is very possible to name the compound like this one. Also, this one here, I have already explained. So, take your pen and paper and try to name these alcoholic compounds. Now, Isomerism in alcohol. Isomerism in alcohol. Because I have already explained the concept of isomerism, there is no need to repeat, explain again and again the concept of isomerism. Now it's better to go direct to the examples of isomers of alcohol, and starting with the isomers of propanol. These are isomers of propanol. The propanol has two isomers. The first one is this one, propan-1-ol. As you see here, the OH group is in the first carbon, so it is the propan-1-ol. And the second is this one, which is propan-2-ol, as OH is in the second carbon. So these are two isomers of propanol. There are two isomers of propanol. Propan-1-ol and propan-2-ol. Another example are isomers of butanol, which are those. The first one is this one. It is a butan-1-ol. You have 1, 2, 3, 4. There are 4 isomers of butanol. The first one is butan-1-ol, as OH is in the first carbon, so it is butan-1-ol. The second one is butan-2-ol, as OH is in the second carbon, so it is butan-2-ol. The third one is this one, 2-methyl propan-1-ol. OH is in the first carbon, so it is 1, 2, 2-methyl propan-1-ol. 2-methyl propan-1-ol. And the fourth one is this one, is 2-methyl propan-2-ol. 2-methyl propan-2-ol, as OH is in the second carbon. So these are isomers of butanol. Isomers of butanol. Another example are isomers of pentanol. Isomers of pentanol. What are those? The first one is this one. Is 1-pentanol or pentan-1-ol. All are the names. Pentan-1-ol. 1, 2, 3, 4, 5. OH is in the first carbon, so it is the pentan-1-ol. This is the first isomer. The second isomer is 2-pentanol or pentan-2-ol. 1, 2, 3, 4, 5. OH is in the second carbon, so it is the pentan-2-ol or 2-pentanol. This is the second isomer. The third isomer is 3-pentanol. It is 1, 2, 3, 4, 5. 1, 2, 3. This is another isomer. It is 3-pentanol. Number 4, it is 1, 2, 2-methyl, 1-butanol. 1, 2, 3, 4. OH in the first carbon, CH3 is in the second carbon. So it is a 2-methyl butan-1-ol or 2-methyl 1-butanol. Another isomer is a 3-methyl butan-1-ol. 1, 2, 3, 4. 1, 2, 3. CH3 or methyl group in the third carbon, OH in the first carbon. So it is a 3-methyl butan-1-ol. Another is 2-methyl butan-2-ol. As you see here, this structure here, it is 2-methyl butan-2-ol or 2-butanol. Also, this one here is 3-methyl butan-2-ol. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 isomers of pentanol. We have 7 isomers of pentanol. It is now very possible to write the isomers of different compounds of alcohol. Now, let us look at the exercise. I have a question here which says, write all possible isomers for the following alcohols. The first alcohol is hexanol. It is possible. By using the examples which I explained earlier, it is very possible to write all isomers of hexanol. Not only that, but also heptanol. It is very possible to write the isomers of heptanol and nonanol. it is very possible to write the isomers of non-anode. Now, take your pen and your paper and try to write the possible isomers for these three alcoholic compounds: hexanol, heptanol, and nonanol. Now, let us explain the preparation of ethanol, or we can say laboratory preparation of ethanol. Ethanol is produced through fermentation of carbohydrates. Ethanol is produced through fermentation of carbohydrates. So what is fermentation? By definition, you can say fermentation is the conversion of carbohydrate or glucose to alcohol, which is ethanol, and anaerobic condition. Anaerobic condition is absence of air, absence of oxygen air. So conversion of carbohydrates to alcohol under anaerobic condition is fermentation. Is fermentation. Now, fermentation takes place in the presence of yeast. Yeast is a fungi which leads to the formation of ethanol and carbon dioxide by the action of enzymes present in yeast, which is called zymase. So the enzyme which is called zymase present in yeast is the one which converts carbohydrate to ethanol and carbon dioxide. Ethanol and carbon dioxide. So ethanol and carbon dioxide is formed in the presence of this zymase, which is the enzyme present in yeast. Enzyme present in yeast. Now, consider the question for the reaction below. This one here. This one here is a carbohydrate, is a glucose. In the presence of yeast, the product produced here is ethanol and carbon dioxide. The yeast, carbohydrates can be glucose or sucrose. The product is ethanol and carbon dioxide. Now look at this diagram. The diagram will show the laboratory preparation of ethanol. For the diagram like this one here, here we have a conical flask. Also here we have a delivery tube. And here we have a solution of lime water. In case in conical flask, you mix sugar, which is a glucose, and yeast. This is a solution of sugar and yeast, or glucose and yeast, carbohydrate and yeast. If you mix them, two products are produced. The first product is ethanol, which is remain as a solution, and the second one is carbon dioxide. The carbon dioxide is passed through the delivery tube out of this conical flask, But we must make sure that no air is allowed to enter into this conical flask. That's why we use the rubber band to cover this conical flask. Now, the reaction here leads to the formation of ethanol and carbon dioxide. And the carbon dioxide used this way, delivery tube, to go out of conical flask. So what's remaining in this conical flask is ethanol. A very simple method of preparing ethanol in the laboratory. Very possible method is this one here. Now, the reaction takes place in the temperature, between 25 degrees centigrade to 50 degrees centigrade. So, the reaction takes place to the temperature between this one, 25 to 50 degrees centigrade. And the optimum temperature is 37 degrees centigrade. Temperature which is required. That's why under this ratio, 25 degrees centigrade, 50 degrees centigrade, this temperature is required for the reaction which I explained earlier. Why 25 to 50 degrees centigrade? This is because at a very high temperature, the active state of enzyme become distorted, and hence the reaction will not occur. Why? The enzyme cannot work at very high temperature. At very high temperature, we say the enzyme will be nature. So the enzyme needs the temperature between 25 degrees centigrade to 50 degrees centigrade. So that's why even during the preparation of ethanol, the temperature which is required earlier is between 25 degrees centigrade and 50 degrees centigrade for that ZMS to work. So the reaction takes place in the absence of air. Also the reaction takes place in the absence of air. Why absence of air? Because the air contains bacteria which use oxygen to oxidize ethanol produced with ethanoic acid. So in case you mix these carbohydrates and yeast, and then you leave it barely without covering, you allow air to enter, the ethanol produced will be converted to ethanoic acid. So instead of getting ethanol, you are going to get ethanoic acid, because the bacteria which is present in air will use oxygen to convert ethanol to ethanoic acid. That's why the reaction takes place in the absence of air. Now, also the reaction takes place in the presence of yeast. Why? Because the yeast contains enzyme called zymes. The yeast contains enzyme called zymes, which act as a catalyst to the reaction. So the reaction here takes place in the presence of yeast, as it contains enzyme called zymes. So the zymes act as a catalyst for the reaction. Zymes is the one who converts carbohydrate to ethanol and carbon dioxide. So the ethanol produced here, the ethanol produced through this process which I explained, has the concentration of 14 to 15 degrees centigrade. Has a concentration of 14 to 15 degrees centigrade. So the more concentrated solution is obtained by distillation process. So after this process, we take this, then through distillation process, we will obtain the ethanol which has high concentration. So these are the processes of producing alcohol or ethanol in the laboratory. Okay, now let us discuss the chemical properties of alcohol. Chemical properties of alcohol. The first is combustion of alcohol. Alcohol burns in air to give carbon dioxide and water. So if you take alcohol, for example, this is the ethanol. If you burn in the presence of oxygen gas, the product is carbon dioxide and water. So any alcohol, even butanol, even decanol, if you react, if you burn in the presence of oxygen gas, the two products which are carbon dioxide and water are produced. Another reaction with sodium metal. Another reaction with sodium metal. Alcohol reacts with sodium to give sodium alkoxide and hydrogen gas. So the reaction between alcohol and sodium, the product is sodium alkoxide, and another product is hydrogen gas. For example, this is ethanol. The reaction between ethanol and the sodium, the product here is sodium ethoxide. It is called sodium ethoxide and hydrogen gas. So this one is called sodium ethoxide. That's what, in general, we can say sodium alkoxide, sodium ethoxide. Another reaction, a reaction with CONCO, or concentrated sulfuric acid. Reaction with concentrated sulfuric acid. How this occur? When alcohol is heated with concentrated sulfuric acid at 180 degrees centigrade, it dehydrates to give alkene and water. So this is a dehydration reaction. Dehydration reaction. This will react with CONCO sulfuric acid under this temperature of 180. The product produced there is alkene and water. For example, this is ethanol. The reaction between ethanol and sulfuric acid under 180 degrees centigrade, you obtain ethene and water. You obtain ethene and water. Another reaction is oxidation of alcohol. Oxidation of alcohol. Now, acidified potassium dichromate or potassium permanganate. Acidified potassium permanganate or acidified potassium dichromate, these are oxidizing agents. So, in case you react this with the alcohol, the different product will be produced depending on the class of alcohol. For example, this acidified potassium dichromate or acidified potassium permanganate oxidize primary alcohol to carboxylic acid. For example, this is ethanol. In the presence of either potassium permanganate and acidic media or potassium dichromate and acidic media, you can choose either to use this or this, either potassium permanganate or potassium dichromate. So if you react this with this, this potassium permanganate or potassium dichromate will oxidize the ethanol to ethanoic acid. Ethanoic acid. So the product which is produced here is ethanoic acid. Another example is propanol. The reaction between propanol and either acidified potassium permanganate or acidified potassium dichromate, the product is propanoic acid. The product is propanoic acid. Also here we have benzyl alcohol. This is a benzyl alcohol. The reaction between benzyl alcohol and acidified potassium permanganate or acidified potassium dichromate, the product is benzoic acid. The product is benzoic acid. So the reaction between either oxidizing agent, which are potassium dichromate and acidic media, or potassium permanganate and acidic media, the reaction with the primary alcohol, the product is carboxylic acid. The product is carboxylic acid. Now, secondary alcohol is oxidized to ketone. Secondary alcohol is oxidized to ketone. For example, here, this one here is secondary alcohol. It is called, either you can call it propan-2-ol or you can call isopropyl alcohol. All are acceptable. Isopropyl alcohol or propan-2-ol. If you react this with acidified potassium dichromate or acidified potassium permanganate, the product which is produced here is called acetone. Acetone is ketone. Acetone is ketone. Acetone is ketone. So the secondary alcohol in the presence of oxidizing agent, it is oxidized directly to ketone. Now, reaction with the carboxylic acid. Reaction with the carboxylic acid. Alcohol reacts with the carboxylic acid to form ester, a compound which is called ester. So how? For example, this is it, alcohol. ROH is alcohol. ROOH, this is RCOOH, this is carboxylic acid. And acidic media, if you beat it, the product is RCOOR, which is ester and water. So two products is obtained. Ester and water is obtained. So this is a general reaction for between alcohol and carboxylic acid. Now let us look at an example here. The example is like this one. Here you have a carboxylic acid here, which is which is ethanoic acid. So the reaction between ethanoic acid and ethanol, the second is ethanol, and acidic media, composulfuric acid. The product produced here is this one. Here you have ethyl ethanoate, and water. Ethyl ethanoate and water. So this ethyl ethanoate is what we call ester. And ester, this is ester. And the reaction is called esterification. The reaction between carboxylic acid and the alcohol is called esterification. It is a neutralization reaction because this ester here is a salty and water. This one acts as an acid and this one here acts as a yes. So what is formed here is ethyl ethanoate and water. Now let us finish by looking at the harmful effects of alcohol. The first, damage of liver. This is the first harmful effect of alcohol. In case of drinking, alcohol can damage liver. Dehydration. Due to the dehydration, can lead liver to damage. Also, damage of the brain cell is another harmful effect. Another one, damage of heart due to the destruction of heart muscles. Even the heart itself is damaged due to the destruction of heart muscles. Also, the alcohol may develop anemia. Anemia is another effect which is caused by too much drinking. Also, alcohol may lead to the impotence due to the interfere with the production of testosterone. Production of testosterone will be interfered with too much drinking of alcohol, so it can lead to the impotence. Another, alcohol is diuretic. That is, it stimulates production of urine. The one who drinks it will urinate too much urinated. So alcohol can stimulate the production of urine. Now, this is the end of my lesson of today. Thank you.